Hello everyone, my name is Meng Wang. Now I'm recording homework 7 of probability and stochastic process. Now let's look at the first question, question 7. Given zt is like this equation, where theta is uniformly distributed from 0 to 2 pi, n1 of t and n2 of t are y-sense stationary, and n1 of t and n2 of t and theta are all independent. First, find expectation of zt, and second, find rzty and t2, and decide whether zt is y-sense stationary. And third, find rz0 if zt is y-sense stationary. So let's look at the first question. Given the information that n1t and n2 of t are y-sense stationary, we could get the expectation of them is eta1 and eta2, and these two are constants. And now let's calculate the expectation of zt. Zt, just replace zt with the equation given in the problem, and we could get the formation like this, and we separate this plus by divided into two terms. Now for the first term, these two are independent, so it can be rewritten as expectation of n1t times this part and n2t times this part. And n1t, we have got the value of it is eta1, and the next part, just use the definition of it. So we could rewrite it as the integral of cosine omega c plus theta from 0 to 2 pi and times 1 over 2 pi. And for the second term, similarly, it has the same formation. And for this term and this term, because cosine omega ct and cosine omega t plus 2 pi, the value of it is the same, so it will be 0, and also this one will be 0, so the final value is 0. And then let's look at the second question. Find rt1 t2 and decide whether it's WSS. rt1 t2 equals expectation of zt1 times zt2. Still, we apply zt1 and zt2 with the equation, and we could get the formation like this. And we separate this to bracelet by cross multiplication, and we could get four terms. First term is this part times this part. The second is this one times this one. The third is this times this, and the fourth term is this one times this one. So we get 1, 2, 3, 4, the 4 terms, and we analyze it one by one. For the first term, expectation of n1t times n2t is rn1 tau, and cosine this part times this part is, we could just copy it down. And for the second term, expectation of n1t1 times n2t2 is eta1 eta2, and the left part just copy. And also the third term is n2t1 times n1t2 is also eta1 eta2, and the left part just copy. And the fourth term, it's n2t1 times n2t2, so it's r into tau, and the left part also rewrite it. So for the first term, we could continue it from this part. The expectation of it, we just use the definition, and it can be written as this. And the second, the second part, n1, eta1 eta2, these two we use the equation, we could write it as sine minus a sine. And the third part, sine times cosine, we could rewrite it as sine plus sine. And the fourth term, cosine times sine, we could rewrite it as cosine minus cosine. So this fourth term, let's calculate it. The second term and the third term are eliminated. So what is left is the first term and the last term. So we plus them together, we could get is 1 over 2 Rn1 tau plus Rn2 tau and cosine omega ct, which is equal to RZT. So ZT is white sands stationary. Now, since it's stationary, it's WSS, we have to find its RZ0. So we just apply the T with 0 into that equation. We could get the final values like this. And now let's look at question 8. Question 8 is Poisson process. It gives us 3 properties. First, find expectation of xt, and second, find RT1, T2. So let's look at the sub first question. For probability of k equals k, x equals k, we could get the formation like this. And if we sum them up from z equals 0 to infinity, it's 1. And we get this part, move it to the right hand side, and we find the differentiation of the two sides, and then we get here, then we times each part of the equation by lambda, then the order becomes k, and here we get a lambda here. And then we rewrite it, we move e to the order omega to this part, we could get this equation, and the left hand side is ex and the right hand is omega. So similarly, we just get the second differentiation of this equation. We could then get epsilon square equals ex minus epsilon square, which is epsilon. So by the above analysis, we could get some useful conclusions. First, expectation of xt is lambda t. Second, expectation of xt square is 1 plus lambda t times lambda t, and cosine xt square is lambda times t. So we have solved the first question. ext is lambda t is here. Now let's look at the second question. Find RT1, T2. For T2 is greater or equal to T1, we could get xt1 equals xt1 minus x0 and xt2 minus xt1. These two parts are independent. RT1, T2 is equal to expectation of the product of the and we rewrite xt2 as xt2 minus xt1 plus xt1, and we separate it from this and this. We divide it into two parts. The first one is this, and the second is expectation of xt1 square. So the first part here, we can use the above analysis and just apply the value here. So this part is lambda t1, and this lambda t2, this is lambda t1, and the square is like this, so just apply it. We could get this one, and the value by calculation we could get is lambda times t1 plus lambda t1 t2. And the second condition for Tn is greater or equal to T2. Similarly, you could get RT1 T2 is lambda T2 plus lambda T1 times T2. So therefore, RT1 T2 equals lambda the minimum value of T1 and T2 plus lambda T1 T2. That's all. Thank you.